matrix, we're looking at the last push for vertical projectile motion. So I'm only going to be speaking about vertical projectile motion. I'm going to be trying to give you a few tips and a few things to remember in vertical projectile motion. Because remember, we all want to get level 7. So you have no choice but to ace vertical projectile motion. Right. Once again, I'm using the examinable content document. Please, if you don't have this document, please ask your teachers for it. You should have it, because this is the document that tells you exactly what you have to study. So let's have a look at the vertical projectile motion. What must we know in vertical projectile motion? Right, one of the first things that we must know is we must know what a projectile is, okay, or a projectile. And a lot of people don't know what it is. A projectile is an object upon which the only force acting is the force of gravity. So we must know what a projectile is. It's important that you know the definition of a projectile, and then you must use the equations of motion to determine the position, velocity, and displacement of a projectile at any given time. Okay. Now please remember that your equations of motion you do not need to learn out of your head. Your equations of motion you get on your data sheet, and there we have our data sheet. Remember, this is given to you, and here your equations of motion are. So please remember that they are on your data sheet. I'm going to come back to the data sheet just now. Right, and then you've got to be able to sketch position versus time, velocity versus time, and acceleration time for free-falling objects, objects thrown vertically upwards, objects thrown vertically downwards, and bouncing objects. You must be able to, if you are given a displacement time or a position time graph, you must, or an acceleration time or velocity time graph, you must be able to determine the position, the displacement, and the velocity. And then for a given graph, you must also be able to describe the motion. Okay, so that sounds very simple. That is all we have to know in vertical projectile motion. So let's quickly go and have a look. Remember, you get given this document, so you know this. Okay. What I like to do over here is I like to remind myself that A is equal to G, which is equal to 9,8 meters per second squared. Okay. I'm going to come back to making it a positive or a negative in a little while, but I want you to remember that. And then the other thing that I like to do over here is I like to draw little graphs for myself so that I can remember what the graphs look like. Right, so first of all, if I have a position time graph looking like this, and I'm throwing a ball up, okay, what happens when I throw a ball up? Initially it moves fast, and then it moves slower and slower, okay. Then what would happen to that object's velocity? Okay, I'm throwing the ball up now, remember, okay. So what would happen? That ball is going to go up, and it's going to leave my hand at a certain velocity. And what is going to happen is that velocity is basically going to decrease until the ball stops. Okay? And because of my graphs, the way they look at the moment, I know that my acceleration time graph would then basically look something like that. Okay, right, let's write up here. So I'm throwing the ball up. That is what, if I do this, this is what I physically see. I see the ball, it covers less and less distance, and the velocity will decrease until it reaches 0. Because remember, up, when it reaches its highest point, is 0. Okay, and if the velocity decreases, then it means my acceleration must be negative. Now I need to remember a few things here. I need to remember, I'm never going to use this one, but I need to remember that the gradient, and please, you're never going to use m. I'm just using m in my, for my little mind map. The gradient of this graph is going to give me velocity. And the gradient of this graph is going to give me acceleration. Right. Then, working it back, the area of that graph is going to give me velocity, and the area of this graph is going to give me position. Okay. In my particular case, we have actually taken down as negative. I'm only going to draw those graphs. And I'll explain to you why. I'm not going to draw the others on my data sheet because I don't really want them there. Because all I need to remember now is, if they had told me to take down as positive, all that would have happened now is my acceleration would have been positive, which means my velocity would have been positive, because remember, here's 0. Okay, that's a positive gradient. Okay, and then this must also have a positive gradient. So this would have been my position time, this would have been my velocity time, and this would have been my acceleration time. And basically, if you have a look at it, they just mirror images of each other. So that is why I just draw the one and I just remind myself of that. Okay. Here are my equations that I can make use of. Please make very sure you write your equation exactly the way it is. Use your data sheet. Okay. Now let's quickly have a look at a question. Okay. In this specific question, they tell me we have ball A, which is projected vertically upwards from the ground near a tall building with a speed of 30 meters per second, and ignore the effects of air friction. Okay. So let us quickly just draw in our mind's eye what is happening. Here's a building. Here's someone is standing and they are throwing a ball up. In plain English, that's what's happening. And you know what? When that ball leaves his hand or her hand, it is leaving at 30 meters per second. Okay. So what is the first question? What is meant by a projectile? I've just told you in your science Bibles, you must learn that. So it's an object upon which the only force is gravity. Right. Now in this specific question, and I want to show you people this very importantly. In this specific question, they've said to me, calculate the total time that the ball will be in the air. Okay. Now, in this question, they have not told you a direction. They've not given you a direction. I personally think at the end of the year they're going to give you a direction because it makes the marking a lot easier. But let's now say they didn't give you a direction. Then the very first step, before you do anything else, you have to decide on a direction. I am going to use down as negative. Okay. So I'm going to use down as negative. So the first thing, when I answer my question, the first thing I'm going to write down for myself over there is down is negative. Okay. If you wanted to say that up is positive, same thing spelled differently. Okay. Now, what else do I know in this picture? One of the things I know is when the ball reaches its maximum height, because they say, yeah, the ball A is projected vertically upwards from the ground near a tall building with a speed of that. Right. Explain what is meant by projectile, and then it says the total time that the ball was in the air. In other words, basically what's going to happen to this ball is it's going to go up and it's going to go down. And now you're going to say to me, Miss, but they don't say that. Ladies and gentlemen, what goes up must come down. So this is what you've got to read into the question. Okay? Right, so they want the total time. I know that at maximum height, whatever maximum height is, my velocity must be equal to 0. What else do I know? I know that my acceleration in this case is equal to negative 9,8 meters per second squared. Why negative? Because I've taken down as negative. Okay. Another thing that I do know as well, and I'm just going to write it in another color because this is going to determine what formula you use. Another thing I know is if it goes up and if it comes down, it's going to reach here with the same velocity. The only difference is, remember, down is negative. So that's going to be a negative. So what do I do now? I go to my data sheet and I see what they've given me. I cannot use any formula with t in it because they've not given t to me. Don't go and try and find t and then work it out that way. Use a formula, or have they given us, oh, they want T, sorry, I have to use T. Right, so let's see what they've given me. V final, I've got. V initial, I've got. Acceleration, I've got, so I can work out time. I would use that formula. What I would not use is a distance formula, because I don't know how high the ball went. So I would now go and I would write down my formula. Vf is equal to Vi plus A delta T. Now you have two choices. I'm going to choose this one. I'm going to say V final is equal to 0. V initial is 30 plus negative 9,8 delta T. And that means that I am going to get an answer so I'm going to say 30 divided by 9.8, and I'm going to get an answer of 3,06. Please make sure, look, this is 3,0612. So it's 3,06. Please do not make it 3. It clearly says you have to round off to 2. So delta T is going to give me 3,06. But now I must remember something. That was only my time up. So therefore, remember the ball went, total time is equal to time up plus time down. Because gravity is the only one acting on it, we're going to have 3,06 plus 3,06, which is going to give me 6,12 seconds. Very important to interpret your question. And yes, not a positive or a negative here, because time can't be positive or negative. Okay. Some of you might have decided to go with this one, and that's why I did this in pink just now. You might have used exactly the same formula. You said Vf is equal to Vi plus A delta T, except now you went and you said, right, that was Vf. So that was negative 30 is equal to 30 plus negative 9,8 delta T. And if you work that out, you should then also get that the time now is 6,12 seconds. Okay. So please make very sure that you interpret the question correctly and that you use the correct formula. You must indicate your direction and read, because chances are good they're going to give you a direction. Now, I know my learners, because I always use negative. The majority of you must probably also do that. If you're really feeling uncomfortable with doing it the other way around, do it like this on a piece of paper, and then just the opposite will happen. Then you just use the opposite. So let's say, for example, you were told pertinently, I'm going to do this in green, you were told pertinently to take down as positive. Okay. Do it the negative way, and then all you do is you go and you change. So that would have been negative, so then that becomes positive. Okay. You're still going to get the same answer. Right. Now let's have a look at our next question. The distance traveled by the ball during the last second of its fall. Right. The distance traveled by the ball during the last second of its fall. Now this is normally quite a problem, people, because we just want to go and change our time. We just want to go and change our time. And this becomes a problem. Okay, so let's quickly see, what do we know? Okay, they want us to only work with the last second. We know that the total time was 6,12 seconds. Okay. Which means the last second is the time from 5,12 and 6,12. Remember, this becomes final, this becomes initial. Okay? And now what do we want to do? We want to know the change in the distance. We want to know the change in the distance. So, what I would do is I would first go and work out, you can do this all in one if you want to, You could say that delta y is equal to delta 6,12, delta y at 6,12 minus delta y at 5,12. That's a bit complicated for me. So what I'm going to do is I'm going to go and have a look at which formula I'm going to use. They are asking for distance here, so I can't use that formula. I could maybe use this formula. No, I can't use this formula because I don't have all the velocities I need and I've been given time. So I will have to use that formula. So I'm going to write down delta y is equal to vi delta t plus half a delta t squared. Okay, so I write down my formula like that. Once again, I need to indicate, I'm going to, in this case, use down as negative once again. So the first thing I'm going to do is I'm going to do this for the time at 6,12 seconds. Okay, so let's go. So that's going to give me delta y is equal to what was my initial velocity. My initial velocity was always 30. My initial velocity was always 30. What was my change in time? I'm busy with 6,12 seconds, 12 seconds, plus half of negative 9,8 times by 6,12 squared. Okay. Now I've got to do exactly the same, except now I'm going to do delta y for 5,12 seconds. Okay. So delta y for 5,12 seconds. I'm not going to get a mark for the formula. So this is still going to be 30 times by 5,12 minus a plus half of negative 9,8 times by 5,12 squared. Okay, right. So now I'm going to do my calculations and let's see what I get. Right, you can do it all in one if you want to. Times by negative 9.8 times by 6.12 squared equals. Right, and I get, we'll check now if I'm right. Yeah, I get delta y is equal to 147,4. Oops. Let's just make 100% sure. This is 40, but that's a 6. So this becomes 41. Okay. Right. Now we've got to do the pink one. Exactly the same. I think I've done something wrong here. Let's just double check. So it's 30 times by 5.12. Remember to put my bracket in. Okay, why am I getting a positive answer? Okay, let's just double check here. Okay, let's do the first one. that gave me 183.6. 0.5 times by negative 9.8 times by 6.12 squared equals negative 183.53. Right. How did I get that answer? So now, 0.07. Is that correct? You can just double check me, Matrix. I'm not having a good day with a calculator, it looks like. So it gives me 30 times by 5.12 equals 153.6. And that gives me that was 5.12 squared gives me negative 124.5. So that gives me 278.11. Okay? And I'm still getting the incorrect answer. Right, I'm going to check it, double check it for you people in a minute. I don't want to waste your time. I did this last night and I got an answer of negative 25.08 meters. I'll double check it for you now. I got that, okay? But now remember, we have to interpret our answer. We have to interpret our answer. And how do we interpret our answer? Oh, yes, mistake, yeah, I see it. How do we interpret our answer? Our final answer will therefore be delta y, or distance, is equal to 25.08 meters. Okay. Because, look here, what they asked us here, the distance traveled by the ball during the last second of its free fall. Okay? So you have to, once you have an answer, that's the answer I got. I have to subtract these two. I'll work through them now again, just now, if we have a little bit of time. I've obviously just made a little bit of an error. I see where I could have made an error here. And then we can see that we interpret the answer correctly. Right there, that's a bit better. Okay, so what happens is I'm going to have to subtract these two from each other, this one minus that one, and I should get that answer. Okay, what I'm trying to show you here is that my answer would have been delta y is equal to negative. You can't leave it like that. Then you are going to forfeit a mark. You must interpret it. And please be very careful when you interpret it, especially if they ask for speed or velocity. If they ask for speed, then your interpretation is straightforward. But if they ask for velocity, you must bring direction into that as well. Okay. Matrix, I'm sorry, I don't know why I keep getting the wrong answer. I'm not having a good day with a calculator, obviously, but I think you should understand the concept of this. Okay. Let's have a look at the next question. Oh, and by the way, it's a good thing maybe that I'm not having a good day with a calculator, because if you had, for example, let me just show you here, if you'd got this answer wrong and this answer wrong, but you still subtracted them from each other, you would still get a mark here. You would lose the mark for the wrong answers, but you would still get marks there and here. Okay, so don't stress too much. Obviously, we want to get level 7, so we need to concentrate on that, but let's see. Right, then they say to us, 2 seconds after ball A is projected upwards, ball B is projected vertically upwards from the roof of the same building. The roof is 50 meters above the ground, and both balls reach the ground at the same time. Refer to the diagram below, ignore air friction. And the first thing they want you to do is calculate the speed with which ball B was projected upwards from the roof. Okay, so let's just quickly go. We've discussed ball A. Now let's quickly go and see what happens to ball B. Ball B is over here, and it's being projected upwards. Okay. One thing we definitely do know about ball B, we don't know much about it is, but we do know that it was projected 2 seconds after ball A. Now remember, ball A's time for ball A was equal to 6,12. Therefore, your time for ball B will be equal to 4,12. Okay, make sure you understand that. Why? Because it was projected vertically upward 2 seconds. So they've given you time here. Okay. You also have acceleration here, which we've already established. We're going to use negative. Okay. The other thing that you also have here, or that I would definitely use, is I would use V final being equal to 0, and I want to work out V initial. Okay. So you can now go and you can work out what you need to do. Let's just see. Calculate the speed at which the ball was projected upwards from the roof. Okay. So let us quickly see if we can work this out. Okay. You could have used, okay, first you have to identify what formula to use. There are various formulas you can use. I'm going to use that one. Oopsie, I'm going to use that one. Okay. I'm going to use that one. There are quite a few things you can do here, but I'm first going to use that one. So I'm going to use VF is equal to VI plus A delta T. Right, so VF is going to be equal to 0, which is going to be equal to, sorry, I'll calculate the speed, okay, which is going to be equal to VI plus negative 9,8 times by 4,12. Okay, and that should give us 9.8 times 4.12. That should give us okay. So that should give us that VI, what have I done wrong? VI is equal to 40,38 meters per second. Okay. Right, let's just double check that. That's 10, that gives you 40, that's correct. Okay. I used a different formula last night and I should get the same answer, but let's just have a double check here. Let's just read the question properly. Ball B is, oh, can you see the mistake I've made? We can't use that time. If I want to use this formula, that's the mistake I've made. Because remember, that is the time, that time is the time it takes to go up and it takes to go down. Right. Okay. So we need to think now. Okay, I then can't use, what I can use over here is I can now use delta y, which is going to be equal to 50 meters. Because remember, there, at that point, the velocities will be equal. Okay, so I can now go and I can choose my formula because now I've got a delta, so I'm going to use that formula now. So I'm going to say delta y is equal to, delta y is equal to VI delta t plus half A delta t squared. Okay, right. So I'm going to have delta y, which is going to be 50, and really important here, we've said that we are using down as negative. And remember, if I look at my picture, what is happening? It's falling down. Eh? So this must be negative 50 is equal to VI times by 4,12 plus half of negative 9,8 times by 4,12 squared. And from there, you should then get that VI is equal to 8,05 meters per second squared. Okay. Now, this is important because this question was 4 marks. I just want to show you here because this is exactly what I mean by the interpretation. This question was, they say calculate the speed at which ball B was projected upwards from the roof. Okay. They ask for speed. So now I must interpret my question. So now I'm going to write here speed was equal to 8,05 meters per second. Okay. Please be very sure, matrix, that once again, you know the difference between speed and velocity. I'm actually glad I made this mistake because can you see why I can't use this? Because that was not the total time. And that was the total time. If I was going to use that formula, I was only going to work with that little piece over there, and I couldn't do that. Right, let's look at the next question. Now they want us to sketch a velocity time graph for the motion of balls A and B on the same set of axes. Clearly label the graph for balls A and ball B respectively. Indicate the following on your graphs. Okay. The first thing, before you do anything else here, people, is go and do these graphs on a scrap piece of paper and do them one at a time. You can do them on the same set of axes. It doesn't matter. Right, let's quickly go. Here's my axis, okay? I'm going to use black. I'm going to use the black for A. Okay, so they want us to sketch a velocity. So velocity is in meters per second, and time is in seconds. Make sure you have that, and we have a velocity versus time graph. Okay, put all that in because that's maximum marks. Sometimes the examiners do that. Give you 1 mark for all of that. So put all that in. Right, now, what happened to ball A? Ball A left at 30. Ball A left here at 30. It went up, it stopped, and it came down at 30. We've already established that we used down as negative or up as positive. Okay, which means when it went up, it had a positive velocity of 30 meters per second. Right, because look there, it left at 30. Okay, then it went up, and what happened at the highest point? It reached 0. Where's 0 on my graph? Over here somewhere. Okay, and then when it came down, it will reach the person's hand at 30 again, except this is negative 30 because it's indicating to me it's going in the opposite direction. So what basically happens here is this ball does this. Oops, my graph is a bit out of proportion. Right, this ball does that. Okay. Maybe it would be a good idea just now when we draw it, I'll show you. Right, so that's basically what happens to ball A. You agree with me? It went up, it reached 0, and it came down. Remember, this is time. Now, what happened to ball B? If this is my time over here, from previous calculations, we know that this time would have been 3,06, because remember, that is what was asked. They wanted total time there, and we calculated it. And this would have been 6,12. Okay. Now, what happened to ball A? Ball B. Let's make ball B in pink. Right. What happened to ball B? Ball B only fell 2 seconds later. Okay. So ball B, we had to have seconds here, so if that's 1. So ball B only started falling somewhere over here. Okay. And we have just calculated that when ball B went past the building, or when it left the hand, it was at 8,05. We've just calculated that. So that will be 8,05. It reaches maximum height, and very important, they tell us They land at the same time. Right. Oh, no, wait, we can't go through naught here. That's when we're going to start. So we start there, and somewhere there it's got to go through 0. Okay? And what happens? It reaches the ground at the same time. Okay, so it's going to look something like that. Please don't let same time, and I want to show you this purposefully. Don't be tempted to say this. Don't be tempted to say that. Because that means your gradient changed. Your gradient can't change, people, because your gradient is your acceleration. Your acceleration is 9.8. So the gradient of these two graphs must be exactly the same. Okay. Right. Now let's quickly check if we draw this graph, what must we have in it? We must have the time taken for both balls A and balls B to reach the ground. Okay. We know they reach the ground at the same time. So that's that. And we must have the time taken for ball A to reach maximum height, which is what we calculated over there. Okay, so this is basically what your graph's going to look like. You don't have to go and draw a detailed graph. My graph, if you have a look here, my 30 and my 30 weren't proportional, so maybe it will be a good idea just to make them proportional so that they're exactly the same. Now, let's say, for example, they said to you they don't want this graph for down as positive. They want this graph for down, they want this graph for down as positive. People, all we're going to do is we're going to give them a mirror image. That's all we're going to do. And let me show you what I mean by a mirror image. All that's going to happen now is I'm going to still do everything. I'm trying to do it so that you can see. I'm going to still do everything exactly the same. Right. So I'm still going to have my velocity and my time, All that's going to happen now is, yeah, my velocity started at 30. Now my velocity must start at negative 30. Now it's going to end at 30. Okay. So all that's going to happen now is it's going to look like that. And can you see if you flip them, that's what's happened. Okay. Right. So once again, if they don't give you a direction, work with a direction that you are comfortable in. If they give you a direction and you are uncomfortable, first go and do it where you're comfortable, and then you make the changes where it's necessary. Okay, right. Just quickly about the graphs. Remember your gradient, as I've already said, must stay the same. Make sure you name your axes and you put in your times. I can maybe just show you here when we mark. You get a mark for the correct shape of A. You get a mark for the correct shape of B, and that they must be parallel. Remember, I mentioned that. And then the times that we've done there. So it's important, that's how you're going to get your mark allocation. The other thing I wanted to mention about this is be very careful because then you just confuse yourself. What some people do is they use a different, they use positive for the one question and negative for the other question. Try and use the same always, unless otherwise indicated. Right. Ladies and gentlemen, that is vertical projectile motion. I know sometimes they combine vertical projectile motion with acceleration, but normally at the end of the year, it's not done like this. Your vertical projectile motion should be something straightforward like this. And if it's bouncing of the balls, it's limited normally to 2 bounces. And so that is what you have to look at. With vertical projectile motion, your big thing is practice, practice, practice. And that's what I want to get to next. You should have somewhere along the line received something that looks like this. Right. It says there, Education Department, and it says Paper 1, Physics, Terms and Definitions, Questions and Answers per Topic. Right. If you have not received this, we are putting it on the system, and you'll be able to work off the system for it because it's 106 pages, so it's quite a lot of pages. But the Department of Education has printed this for every single learner in the Free State. So you know what? Hound your teachers and ask them for this. Okay. And I just want to show you what this is about. This document took quite a while to compile, and you are really lucky that you have this. Right, it has questions and it has answers. There are all your terms, all your definitions that you must learn. How easy is that? And remember, if you want to get level 7, you've got to know every single one of those. Then your questions are, there's your Newton's laws questions. And you will see that most of the questions go up to question 7. Okay. Your question 6 and 7 questions are a little bit more difficult. Okay. Right. Now, here's vertical projectile motion. These questions are questions that all of them came out of the previous exams. So you know what? If you can do all 7 of these questions and you understand all 7 of these questions, there's no ways that you cannot get a level 7. Now, a lot of teachers have been fighting with us because they said to us, why have you given us the answers? Now, let's quickly see in this specific question. I'm going to show you which question I did. Did I do this question? Yes. I did this question, which was a question 6. So if I now go to my answers, I just want to show you. If I go to my answers, that's too far. If I go to my answers, you will see that the answers are here. Now, a lot of people said to us, but why did you put the answers in? Because now the learners are just going to go to the answers and look at the answers, right? Here's the question I did. The reason we put the answers in, and this is for you level 7 learners, you must make use of this. You would have gone and you would have done question 6. Okay. Now, say, for example, you did question 6.1. Can you see how many, 6.2.1, how many different options there are for you? Right. And now you can check. Let's say, for example, you used this upward one here, but you didn't make that a negative. Now you can go and you can check and you can say, no, why didn't I make that a negative? Oh, I should have made it a negative because it was falling down. Right. And this is how you are going to improve your marks. You have to go and look at these. You don't first go and look at the answers. You first do that and then you have a look. And the important thing here is to identify your mistakes. Right. This is the question where I made so many mistakes at question 2. The mistakes I made were just calculation errors. But there's one option and there's more options that you could have used. There's another option. Right. Okay. And then here we have our graphs. And if you have a look here, we've actually given you both ways of drawing the graphs. Okay. So please make sure that you get this document. It really, really is. If you go and you do every single one of these questions and you can understand every single one of these questions, there is absolutely no reason why you cannot get a level 7. But you know what? You've got to sit down and you've got to do those questions. Have fun doing vertical projectile motion. Bye.